let's wind up on the third episode on application of these codes. So we'll look at the application of these codes and then we go and write a simple program. We am able to explain this. I think I did an introduction previously. We discussed on the of this part program, basically using what we call word address format. In a word address format, this is the syntax or the format for using G01. So which means G01 is what you call the linear interpolation. You are now cutting. So you need to put either the value for X, Y, Z, and also F. So in this scenario, this G01 normally denotes linear interpolation. Moving in a straight line, it may be vertical, horizontal, negative, or positive, diagonal. Or this one means we're cutting a chamfer. In this, it must also have a fit rate. If you're using G01, it must have a fit rate. If it is not, there's no fit rate, the machine will give you an error. So here, most cases, if you are moving, you have two scenarios. Either we can use what you call point-to-point movement or continuous or a line. If you have a point, let's say, these are the points. These are the points making the profile or the contour. The tool will come to this point like this. Come to this point, then it goes. So we call it point to point. You use point to point. In the previous session, I explained how to identify points using absolute and incremental, so that if you are programming, you now use the point to point. Maybe for the sake, I will also come and explain the linear movement. So which means here you are positioning the tool, for example, from point A. Now using G00, it comes to point B. Then here we now use G01 to start cutting. G00, you are just pushing the tool to come from point A, point B. When it switches here, now you start cutting. An example, for example, if I write G00, X1, Z1, I want to position my tool to come to X1, but Z away by 1, then now move closer to Z.1, and then now start cutting. If you see G01, it has the value for Z negative and a fit rate. Now here you are now cutting. You're now cutting. For example, if I was using this drawing here, I will have my X. You have my X30. So I will put here. I'll put here G01. X is 30. Z is 0. If my 0 point is here, then F I can put maybe let's say 10. Or let's say 100 because I'm turning. Then I can go to X next X. I can write X 30 again, or I can ignore right because it's the same. Then Z I can say minus, let's say minus 20. And then I can go to X. I go up to X40. Z is minus 20 still. I can go up X40. Then Z is minus 80. See? Minus 80. So if I use absolute program, it means all my points are coming from here. What is called a system? All points are coming from here. So in linear interpolation, this is an example of a program if you're using linear. So that here I've not put G00 or 0, sorry, G01. I'm using now model. So it is model, it's still active. Until you finish, you now actualize, let's say G00, X maybe 100, and then Z 100, then M05, M09, M30. So this is a program, a part program you are able to actualize it using G01. When you go to G02, what you call circular interpolation, as I said previously, circular interpolation, it means you are moving a tool in the clockwise direction, but circular. You're moving a tool in the clockwise direction, but circular. You see here, if I was moving from this point to this point, to this point here, maybe this point 1, point 2, point 3. So I will move linear and then circular. So if I go this direction, it becomes what you call clockwise. So I will be using G02. But here it is linear. So here it is linear. And then I go, if I using this direction, it goes G03. because now it's going anti-clockwise. For you to understand how to use circular interpolation, you must identify where you are starting. Here, I'm starting from this point. So this is my starting point, the center. So this is where I'm starting. We call it starting point. This is where I'm starting. And then this is direction. I'm moving the anti-clockwise direction, which means this becomes the radius, r, and then this is the end point. So I'm ending from here. If I take these values like this, I will have this curve. So this is the curve, this is the origin, this becomes my r, my r. This is where I'm starting